Okay, everybody, let me get started. First, again, welcome to the first talk at the Agentic Coding in Practices seminar series. My name is Saman Amarasinghe. I am a faculty member in EECS at MIT as well as a member of CSAIL or Computer Science and Artificial Intelligence Lab. So let me give you a little bit of motivation why I am trying to start this seminar. So basically, I started programming in about 1981 when my parents brought me a Sinclair ZX81, 1K memory all, but it was fun. Over the last almost now 45 plus years, I have seen so many changes in programming from languages start from BASIC, Pascal, C++, Java, Python, all those languages going on, way how programs are written, so many changes, the tools we are used. But until now, all the programs were written by programmers. And programmers decided data structures, control structures. Programmers did everything. Today we see this huge change happening, and I think it's bigger than even sometimes a lot of us think. What we might end up happening. The other interesting thing is, a lot of times these kind of large changes happen. They first get incubated in universities for sometimes even decades before they come out and become very well known and popular. This is one change that came from the other side. It came from industry into universities. So sometimes I feel that in a university we might be behind. So it's good for us to learn from the best practitioners of the craft. So that's why today I am so happy to have Jason Ansel. Jason did his PhD at MIT. In fact, he started working with machine learning techniques 15 years ago when it was kind of completely out of fashion. Nobody was doing it, but Jason's thesis had a large component of machine learning. And then he worked in multiple companies. And then when he was working in Meta, he had this side project that then became PyTorch 2.0. So now he leads the PyTorch 2.0 team, and he's doing some really cool stuff with agentic programming. And we are here to learn, Jason. Floor is yours.
All right, thanks for having me. I'm excited to give this talk. So a bit about background on me. Saman's covered some of it. I was in Saman's group, back 15 years ago, and this talk is definitely Saman's idea. Saman and I were having dinner, and I was sort of talking a little bit about how I was using agentic coding now. And Saman's like, you should give a talk about it. And so I agreed, and that's how we're here. I've done some startup and people management in the past, but the past 6 years have been technical lead on PyTorch compilers. I started Torch Dynamo and Torch Inductor, which became Torch Compile, PyTorch 2. Recently, I've been working on a DSL called Helium. Both these projects and also a lot about how I use agentic coding involve lots of help from others, and too many people to name, but definitely a group effort, and I couldn't have done it without lots of help. So I'm going to start with some disclaimers. So this is a talk about how I use agents today, and it changes super quickly. So this would have been a completely different talk a month ago. I think it's going to be a completely different talk if I give it again a month from now. This is going to have a really short shelf life. And others use agents differently. There's a lot of variety here. This isn't a prescription. You should do what works for you. These are my personal opinions. And a brief timeline for context. Sort of summer last year, I was using ChatGPT as a debugging tool. I sort of when my compiler produced code that was wrong, I paste the output code into ChatGPT and I'd say, find the bug. And it was really good at that. But it really was in the fall that I started experimenting with AI agents. And I sort of found a workflow that worked for me. Back at the time, a lot of people were doing different things. And I really stopped using IDEs in November or December of last year. I haven't opened an IDE this year. It's just been entirely AI-driven coding. And so this is a really big mental model shift. So I used to, really be building code myself. I'd be hammering the nails. If you sort of think of the analogy of building a house, I was both designing the house and framing the walls and nailing things in. But my role has really changed now to more of sort of designing and supervising, where I'm still very much responsible for the design of the engineering, but the actual sort of hammering of the nails and sort of low-level work is now done entirely by AI agents. And this is really a different skill set. It's exercising my code reviewing skill set, which I do a lot of for humans. It's exercising a lot of my people management skills. So I think my experience managing teams has made me much more able to do this type of coding. And it also requires a lot more multitasking than traditional coding. And if I had to sort of distill my advice on how to use AI agents down to sort of a single line for this entire talk, it's you be annoying. You are responsible for the design and the code that's produced. And so if you're sort of going to this build a house analogy, you should be asking the agents to repaint, move walls, tear it down and start over. The cost of redoing things is really low, and so you should set a high bar. And basically, as you're reading the code, you should, if something isn't perfect, you should be asking the agent to change it. And so the biggest challenge and the biggest sort of pitfall of using AI agents today is this sort of slop factor. AI agents, when they're writing text or generating images, everyone is familiar with AI slop, and AI slop is a huge problem in agentic coding. And so if you're dealing with a pretty small project, like if you're writing a script, or you're saying go through my Git history and sum up the statistics, you don't use that many tokens. It's a pretty small task. And so this isn't really an issue. But basically, as sort of time goes on, if you're working on larger and larger projects, your code base sort of starts getting messy, and then eventually becomes an unmaintainable nightmare. The real key to getting good results with agents over time is providing quality human feedback along the way. Basically, providing that pressure to simplify and apply good software engineering techniques is really the difference between sort of an unsupervised agent sort of going off the rails completely and sort of having a code base that can really scale and be maintainable to larger projects. It looks like there's a hand.
Is there a question, Nick? By the way, Jason, if the window is fully sized, I see a little bit of a cutoff on the bottom and the right side.
Let me try sharing. How's that?
Oh, that's much better. Ooh, now we can see a lot more. Okay.
Okay. All right. Basically, and this is really, I think, the key to scaling the way agents work is providing this feedback along the way. So, how do you give feedback to agents? How do you be effective at sort of steering the agents in sort of this direction towards sort of higher quality code? And so, especially for talking to more junior folks and sort of coaching them on how to do code reviews. This is just basically just general code reviewing skills for a lot of this. Is that the biggest sort of mistake is you should not treat doing a code review like reading a book. you should really be understanding the high level structure, and especially with agents, you should be providing pushback, and it should be a dialogue. And so if I had to sort of distill it down to a short phrase, this is a phrase that I think Ed Young said that I'm taking is it's read less, steer more. So the agent is helping you realize a design in your head, and you should not feel an obligation to take whatever the agent gives you at face value. You should be pushing back and really shaping the structure of the code. And so how do you do that? Well, you need to ask the agent to explain things. It's really a dialogue. And I think a really good way to do this is to make the AI agent justify its design decisions. Like as you're reading the code, if something doesn't make sense to you, say like, hey, this doesn't make sense. Are there any ways you could simplify it or make the code clearer? You could ask, if something's complicated, ask the agent to simplify it. You provide sort of that pushback and that dialogue, and that dialogue is useful for two reasons. One, it helps you understand the code, right? It's a lot easier to ask questions and have sort of a dialogue. And it also, I think, makes the agent think about the problem more. And often, when I ask an agent questions about why did you do it this way? The agent will say, oh, actually, there's a better way to do it. And I'll just be like, oh, yeah, we'll redo it that way. And so it's this pushback and dialogue with the agent that sort of causes the code to get better. So then another big tool is you can use agents to check agents. I use both Claude and Codex. I usually have one Claude terminal open and one Codex terminal open in every workspace I'm working on. And I'll have Claude review the work of Codex, and I'll have Codex review the work of Claude. And you can also do self-reviews. So you can use sub-agents. You can say something like, at the end of your task, use a sub-agent to review your changes and address any issues. And that sort of is a good first pass because it's very cheap. It doesn't require any human attention, which is more expensive than tokens. You can also do things like ask for manual testing and benchmarks. And I think there's a lot of value in sort of using agents as a way to sort of clean up the code that agents produce. But there's lots of pitfalls of agents. There's lots of cases where things cause problems. So agents often move the goalposts. So, one thing they sometimes do is they'll modify tests. Like they'll change, if your test expects the correct output, they'll modify the test expectations to expect the incorrect output. Or they'll, add a skip or an X-fail to a test that shouldn't be skipped and X-failed. They often declare things partially complete or stop early, and one of my most common prompts is like keep going until it's fixed. Or sometimes they just one word prompts continue are pretty common. It often also doesn't fix the root cause. Like if I ask an agent to fix a bug, it'll often put in like a really narrow if statement that like only changes the behavior for that one test and doesn't sort of find the root issue. And when I see that, I need to actually identify it and say, this fix isn't fixing the root cause. Try again and fix the root cause. There's a lot of code quality issues. So code duplication. Like agents really like to just copy and paste and not reuse things when they should be reused. It doesn't introduce abstractions that could allow reuse. It often will violate abstraction boundary. It'll reach into sort of the private internals of objects. I also see often overly defensive coding where, rather than just reading an attribute, it'll say, well, if it has the attribute, then do it, or it'll put an except statement. And the problem around that is it hides bugs. Like suppose I rename the attribute, all of a sudden, the code just does nothing, and rather than throwing an error, it just silently causes issues. And so these are sort of some of the pitfalls that I often see. Some of these have gotten a lot better over the months, but it's definitely, the agents aren't perfect, and they require a lot of effort to sort of get good results from them. All right, context windows. So one of the most important things to keep in mind when using an agent is the context window. And so if you're in the CLI for Claude, in sort of the bottom right, it says X% of context window remaining. And one thing you'll notice over time is that agents are a lot better early in the context window than late in the context window. So early in the context window, they're very steerable. They're easy to guide. I think they're like more clever and good at getting things done. And late in the context window, things get a little wonky. Like the agents just get a lot less good, and often they get really stubborn. Like you give them new instructions, and they'll go back to the instructions in the beginning of the context window and just forget your new instructions, and stuff like that. And so you should be explicitly resetting your context window pretty often. There's lots of different ways to reset your context window. You can type /new to get a new context window. You can type compact to automatically summarize the current work and then start a new context with that summary. I often want more control over that. Those automatic summaries often don't take the important information that I want, or sometimes they'll have too much information that's not relevant. And so you can create a new context, and then at the beginning of your next prompt in the new context, you can tell it what to do for context. So I can say, hey, review the state, the Git changes for context, or go to this planning document. I'll talk a little bit more about planning documents and later on, or like look at this website or this Git issue for context. And then another thing I like to do is I'll create a new context. I'll ask it to do a code review, and then rather than addressing the review comments, I'll just hijack that for a new task. And the idea is, especially for things like refactoring, where you really want the agent to understand the code really well, having it do a code review is a way to force it to have a context that's populated by a concrete understanding of the current state of the code base. And so this sort of managing the context window, I think, is a really, really good trick. And this has gone a lot better recently. I'd say a month or two ago, this was significantly more important than it is today, but it's still, I think, a big issue. So skills. Skills are basically just saved prompts. So, and there's been a lot of sort of hype about skills recently on Twitter and stuff like that. But basically what I'd say is, if you find yourself typing the same prompt over and over again, create a skill for that. There's nothing magic about skills. They're just a way to save the specific prompts. My advice for writing skills is to keep them short and to the point. Too long and you're wasting that sort of early valuable context window. That's sort of the good part of the agent. And so if you have too much cruft in your Claude.md or in your skills, you'll end up sort of burning that. If you're using both Claude and Codex like I am, make sure you symlink the files, because they use both the different file names, both for skills and for the agents / Claude.md stuff. I think you can also use agents for learning. So it's never been an easier time to ramp up on a new code base. If you're trying to figure out a new code base, you can ask the agent to explain it to you. You can ask it for examples. You can ask it if you're trying to figure out how does X work. You can ask it that. If you want to design a new feature, you can ask it to brainstorm ideas with you and sort of be your sort of brainstorming buddy. And agents can also do research. You can ask the agent to search the web. I think if you want like a really extensive web search, I think the deep research tools from the web UIs are still a lot better for that. But I think you should definitely be like, if you're trying to use a tool, you should definitely ask agents how to better use it. My next piece of advice is to use higher level abstractions. So often I'm having conversations with folks about how they use agents, and some people just have a lot less success than I do. And one of the most common reasons that I suspect the difference is that when I talk to people who are primarily using C++, they have a lot harder time using agents than me, who's primarily using Python. And so I've had a lot better results with Python than C++. I've had a lot better results with Triton than CUDA. And I think that the agents, as of right now, are just way better at higher level languages, and you're going to have a much better time if you stick to these higher level languages. Similarly with libraries, just like languages can be high level, a lot of things, there's a library for that already. And so, if maybe the library, you can tell the agent to use the library. You can tell the agent to search the web and try to find a library to use for something that should have a library for it. And you're going to get better results. And if I needed to implement something low level, actually what I would do is I'd first have the agent implement it in a high level language and then translate it. Because agents are really good at translating, for parts of PyTorch that are too slow because they're in Python. I've had agents, rewrite them in C++. There's some pitfalls there. We had a memory leak because an agent forgot to decrement a ref count. I've seen some data races introduced by agents. So what I'd often do, that you have to be really much more careful than low level languages. And what I'd actually suggest is you can use basically an adversarial agent, have one agent that does the translation, and then a second agent that vets that translation. And you can specifically task that second agent with, audit all of the reference counting and make sure the reference counting is right. And that's a great task for a brand new agent in a brand new context with them. My next piece of advice, and this is some cases where people have worse results than me, is don't waste your time with small models. You should always be using the largest models available. I use high reasoning or better. The gap between these frontier models, mainly just Claude and Codex, and even where they were a month ago is really huge. I hope that open models will catch up at some point, but right now, if you're using anything other than the biggest models, you're really wasting your time. So now I'm going to talk a little bit about my development setup, like what I actually use. So I use Docker for isolation and sandboxing. Docker allows me to basically get a isolated development environment for a specific task. And I usually have between one and four of those running at a time. I have one Claude and one Codex running in each container. And I'm using YOLO mode, which is these dangerously skip permissions flags. I think both these agents are basically unusable without YOLO mode right now. I have a bunch of security concerns about this, so I'm very careful with untrusted content. That's part of why I'm using Docker, is that it doesn't have access to my full file system because in an isolated Docker container. But I've also heard that coming pretty soon, there's going to be model-driven security environments, and so I'm looking forward to basically the vendors here providing a safer alternative to YOLO mode. So I use both Claude and Codex. I'm using the CLI versions of them. Which one I prefer changes really week to week. So, last week, if you had asked me, I would have said Claude was better. As of Codex 5.5, which just came out a few days ago, I actually think Codex is a little bit better. But as of the state now, I'd say Claude is faster, but Codex is slower, but does a little bit of a better job. But really, this flips back and forth constantly. So I'm sure that the next Claude release Claude will pull ahead, and so on. And then also PyTorch has lots of really great integrations on GitHub. So I can comment on a GitHub issue. Like one of my most common comments, if you spy on my GitHub history, is I like go at Claude, what's going on with those CI failures? Because tracking down CI failures, reading through hundreds of pages of logs is a huge pain, and Claude just automates that for me, which is fantastic. Okay, so some examples of some common prompts. So these are sort of like I just sort of went through my prompt history, and I'm like, okay, what are the prompts that I'm using, basically every day or really frequently? And so probably my top ones are fix things. So fix the lints, fix the merge conflicts, fix the CI failures on this URL. Like if you just paste in a git URL, these agents will figure out how to pull down the right context from that. You also need to actually be super verbose. So if I just have a test failure, if I just paste the test failure into the CLI, the agent will figure out that it's got to fix the test failure. You don't need to actually say, please fix the test failures in the following error message. You just give it the error message and it figures it out. You can also do stuff for munging on your Git history. So for example, I can say split this commit into 3 commits because I want it to be easier to review when I submit it. Here's some examples of, so PyTorch is a big project. We have, thousands of GitHub issues. So a really common thing I'm doing is I'm on call every month or two, and when I'm on call for PyTorch, I'll do things like, help me fix the following GitHub issue. First, reproduce it locally and verify it's real. Stop if you can't reproduce the issue. I'm doing that stop if you don't reproduce the issue because we get a lot of out-of-date issues that are about old versions of PyTorch. And then I tell it to go and fix the issue. And I'd say, most of the time for small issues that are actually real issues, the agent's able to fix it. And it doesn't actually need a lot of context for this. Just a GitHub URL is pretty good. You can also use it for triaging tasks, go through, all the issues. So we have a flaky test problem, and I can tell it to go through 50 flaky tests and then try to reproduce them all and give me a summary. So it is great for sort of project management type stuff. These last 2 ones are good candidates for turning into skills. The skill versions of those could likely be better, but I haven't turned those into skills. I actually from before there were skills, I basically had a document of common queries I used that I copy and paste from, which is sort of like proto skills, and I still use that a little bit. So now I'm going to go through a bigger case study. So this is a larger task that has taken a few weeks, sort of part-time. It corresponds to about 20 pull requests, 22,000 lines of code. More than 1,000 user turns and 150 sessions. So you're noticing that for every pull request I'm making, I'm taking about 50 turns with the agent. So I'm actually having a lot of conversations back and forth for every pull request I submit, and also 5 to 10 sessions. So I'm starting new sessions pretty frequently, and I'm using many different sessions per pull request. But when I think about the workflow I'm following here, I think there's 3 basic phases. There's a planning phase, and I'm going to talk about all 3 of these phases. There's an execution phase, and there's this verification review phase. And I find myself basically alternating between these 3 phases approximately once per pull request. Although sometimes I'll go back if the pull request ends up being really small, I'll end up combining it with another one. Planning phase. How does the planning phase work? So I highly recommend having the agent create a planning doc. And so in this example, I have this planning doc called cuteplan.md. And I use this to manage the work. And this is a really good way to make the agent think about a task and also like have a complete specification of what it should be doing. And it also allows me to track work across multiple agents and sessions. So this planning doc can be shared between Claude and Codex because I'm using both of them. And also when I reset the session, I can tell it to go back to that planning doc for the context it needs. So I don't write the planning doc. I make the agent write the planning doc. So this is the initial prompt that I used to create this planning doc. But after I gave it this, and this is basically sort of, it's telling it where to look, it's telling it to make the plan, but it's not really being very prescriptive. But then after that agent had the initial text of the plan, I had then maybe about 100-turn conversation to refine that plan. I went through the plan. I actually did do some manual edits to the plan. This is a back and forth. And I just found this process easier than writing it myself. Mainly because, like, you know, when you have a blank piece of paper, it can be hard to get started, and having sort of the agent start with something and then iterate back and forth with that plan is, I think, it at least helps me and saves me time. I also think it can be helpful for the agent. Like, you know, when if I were, you know, agents are a lot like sort of junior software engineers, and if I'm working with a junior software engineer and I want them to do some sort of task, often, you know, I won't give them a complete specification. I'll make them think through the task, because I think if you make someone think through a task and actually think about the trade-offs and actually do some of the planning themselves, they'll have a much better understanding of it. They'll also think about things that are sort of like implicit in your head, where you just sort of assume X. Maybe they won't assume X, and so I think that having the agent be involved in sort of the planning document creation is really important. Then after every task is complete, I'll prompt the agent to update the plan. I'll often, you know, in sort of subsequent steps, I'll end up deviating from the plan. So the plan sort of is constantly changing. It's definitely not fixed in stone. And often, like, this planning document lives across 20 PRs and counting. So I'll often come back with a larger update. So I'll say, here's an example of a query I used for a larger plan update. I said, okay, run these benchmarks. Compare against, an existing state-of-the-art implementation, compare the output code, run an ablation study to understand where the performance differences are, and then update the plan with the concrete features needed to close the performance gaps based on the ablation study. So that's sort of a case where, like, we had got the back end to the point where it was functional. It wasn't quite as performant as I wanted it to be. And so I basically asked the agent to go run some experiments to figure out, okay, how do I make this go fast? That sort of allows data-driven plan updates. So it's often the plan updates involve writing code and running experiments, but just it ends up being sort of throwaway code.
Jason, there's a question saying, looks like you have all these different conversations. How many of them are just simple things like fixing a lane type stuff versus some deep knowledge required in these conversations?
I'd say it's like 20% deep knowledge, 80% very mechanical type things. Like I think my most common prompts are like, fix the tests, continue, implement this work. Do you have a test for X? I have some more examples, but I'd say most of them are not super deep, but there is a chunk of them there. All right. So execution phase. This is sort of the next phase after I've done the planning. And so the work of the execution phase usually starts based on the plan. So, I often will say, after the agent finished the previous task, I'll say, update the plan and suggest next steps. And so basically the agent will go and read the plan. It'll suggest sort of the bullet point list of maybe 5 things. That's not always 5 things, but it's usually about that. I'll then call compact explicitly, because I want to start the new task with a fresh context window. I don't want to be like late in that context where the agent is really wonky. So I call compact explicitly. I'll then say something like, implement, 1, 2, and 4, then use the cute verify skill to check your work. There then sort of becomes, a series of time where I'm basically just nagging the agent to finish the work, because often the agent will stop before it's done, and I'll have to tell it, you got to continue. You didn't finish. Sometimes it'll finish. But it'll then if you read the text that it says when it finishes, there'll be obvious problems with it. It'll say hey, I finished the task, but the tests are hanging and they're just timing out. And so there's the obvious follow-up prompt of okay, well, fix this error you just told me about. This is pretty annoying that it does this, but agents definitely do this a lot. And then even when it does say it's done, I think it's good to probe it a little bit to make sure it's actually done and not fake done. So if I'm implementing something and I'm worried about a specific corner case, I'll be do you have a test for this corner case? Or I can even just ask it more open-ended questions, what are the gaps in this implementation? And it'll suggest a bunch of things, and sometimes it'll point out huge glaring flaws in the implementation, which it should really fix. And so there's sort of a bunch of steps where, I think this phase is sort of the most prime for automation, because there's very, very little deep thought involved here. It's just mostly it requires a ton of nagging to get the agent to actually finish its work. So the next phase is verification and review. So first I have the agent check itself. So it runs all the tests, it runs some benchmarks. I'll use a sub-agent to do a code review. I have these three things in a cute verify skill, so I'll just tell it to use the skill. I then swap to a different agent, do a code review with a different agent. Having an agent do the initial review is a lot less work than me doing it. And then finally, once I've sort of exhausted the automated feedback, I'll do human feedback. And so I gave a bunch of examples of some feedback. This is anything from something really minor, do these refactors, do these renames, to more fundamental things where I think the design might not be robust. I wanted to do some changes. And this sometimes if I've caused a lot of changes in this human feedback phase, I'll go back to the machine feedback, and I'll bounce between human and machine feedback a little bit until I feel like the pull request is really polished enough to be submitted. All right, so that sort of covers what I've been doing. This is sort of my second to last slide. I'm going to talk about what I think is coming in the future. So as I said, things are changing really fast. And I think a lot of the steps I talked about today are primed to be automated. I don't think anything I really talked about today is safe from automation going forward. We're starting to see early cases of this and some success with fully autonomous feedback loops. So the idea is if you have a really measurable goal, make this GPU kernel run really fast. You can have a no human in the loop feedback loop where you just automatically just prompt agents to make it better, make it better, make it better, make it better. Run 100 experiments, keep the 20 that works. I think there's a really good example of here. This is this auto research project. This is from Karpathy. This is a system that sort of does these sort of fully automatic feedback loops, sort of improving things while you sleep. But lots of people are trying these types of things, and I think that this is probably where the future is. The real challenges of this right now are the output code of this is currently an unreadable mess. It's really hacky code. You look at these kernels that are generated through these processes, and they're just giant switch statements where they've copied the entire kernel over and over again, and it's really real bad. But I think we're going to improve this stuff. I think there's also some people who are predicting that maybe we'll get to a day where humans aren't going to be able to read code and only machines will be able to read code. I'm a little skeptical of that, but I've definitely heard that argument, and we'll see who that's right. There's also cases in this where you can see reward hacking. So we also saw one case in a kernel competition that we ran where people actually or an agent submitted code that would detect whether it was in the correctness testing phase or the performance testing phase, and it would run one code under correctness testing and then a different, much faster, less correct code when it was under performance testing. And so you got to watch out for those things. But yeah, it's definitely an exciting feature. And so as I said again, things are changing super fast. I think the expiration date of this talk is very soon. Thank you for listening. Hopefully you found this valuable. And a quick plug for Helium DSL, which is my main job these days. We're giving a tutorial at PLEI, so if you're at PLEI, stop on by. And I'll take some questions.
Okay, thanks, Jason. So let me ask you one question that a lot of people in academia is very worried about: correctness. Like if you look at places like PLEI, it's filled with trying to make correct by construction, proving correctness, all those things, and they're all like freaking out that now you have a prove to be incorrect system that prove to be nothing correctness is now we are relying on that to write our code. How do you deal with correctness? What's your experience in getting correctness out of it compared to, for example, a human programmer?
So correctness is a huge problem. So one thing that, in asking agents to optimize kernels, one thing I've seen it do is just, delete the memory fences because it's faster without the memory fences. And, that's obviously, that's correct most of the time, but then it introduces data races and so it's definitely a big challenge. I think you can also use agents to help with the correctness thing. You can have an adversarial agent, and your adversarial agent job is to find the bugs, find the data races in the code generated by the first agent. And we're actually seeing a lot of examples that these sort of adversarial agents looking for bugs can be more effective tools for debugging than humans. You probably have seen the news about Mythos finding bugs in Linux and OpenBSD and Chrome, and so Mythos is finding 20-year-old bugs in OpenBSD that decades of security researchers were unable to find. And so I think we're rapidly reaching the point where agents are actually better at finding bugs than humans, but you definitely need to create those loops where you're asking you have sort of your correctness checking agent whose job is to find the bugs, and that's sort of auditing the code of your other agents. But yeah, for sure, reliability and correctness is one of the biggest issues today. But it's also something that agents can solve.
Okay, I have two more questions. By the way, if others have questions, can you please type it on the chat so we can do that, or you can raise your hand and ask. Look, let me ask one more question and then give it to Tommy. So there's this excitement now that because these agents can do a lot more work, we can actually get them to write proofs. So there was a time people want to build things with proofs, but humans were very lazy about didn't want to write the proofs. Do you think that's a path that the things you build, you can actually also get a couple of agents and around it to go write the proofs for it?
Maybe. I think for very large systems, how would you even go about writing a proof that the Chrome web browser is correct? Well, one of the problems is you need some sort of specification of what the Chrome web browser should be doing. And the job of writing the specification for the Chrome browser is just as hard as writing the Chrome browser in the first place. And so, you could do more narrow proofs. You could say proofs of no data race, like proof is deterministic, you could prove specific properties, of a program. And I think there's definitely room for that kind of stuff. I think the competition is just going to be, we'll ask the agent to find the thing, and if the agent can't find the thing, then sort of similar to how Mythos is finding bugs in all these old pieces of software. Eventually, if the agent gets good enough, well, if you ask the agent to find the bug and it couldn't find the bug, that's a pretty high evidence that the bug doesn't exist. A proof would be wonderful. It's just really hard to come up with reference implementations and make them scale to large projects.
Thanks, Tommy. Go for it.
So, if we compare this to a little more, what should I say, human-centric development, where we have a design, we have a product coding phase, we do some initial verification of ourselves, and then we kind of rely on other tools normally. Those two kind of phases where for coding and doing this initial debugging, how much is your sense of the speed up you're getting from this, from using AI to kind of writing it fully for you?
Oh, as I said at the beginning, AI agents are a lot like junior software engineers who've read basically every book on the internet and have amnesia where they forget everything constantly. And so a lot of the ways that I deal with agents are exactly how I deal with human software engineers. And there's a lot of ways where dealing with agents is better than, or more pleasant than dealing with humans. Like the agents follow instructions better than humans. The agents are a lot faster. Where if I do a code review of a human pull request, it might be like a week before the human gets back to me. Well, the agent is back to me, in 20 minutes or an hour. And so the time cycle is a lot shorter with agents. I can also just be a lot ruder than the agents, where if a human proposes a design, there might be like a bunch of things in the code review which I sort of let slide because I'm like, oh, it's a stylistic thing, their way is fine. But because it's not a human, I can be like, no, you must do it my way. I don't really like this. Do it again, but make it better. And so you can just be more annoying and more obnoxious when you're giving agents feedback. But yeah, there's a ton of similarities to humans. I think that agents are not as good as the best humans right now. I would much rather be working with sort of the top, 10% of humans than agents. But it's better than a lot of humans are already today, where there's a lot of tasks where I would trust giving it to Claude more than I trust giving it to sort of a median software developer.
Okay, I found that at least coding in C++, that I have to prompt it more than my junior engineers to get it done. So the payback isn't that obvious.
As I said, this one, I sort of had the same thing where I've had a lot better results with Python than C++. And so I think that there are pretty big gaps in the lower level languages, as I mentioned.
So there's this question asking what's your best guess on what will happen in 1 year as far as capabilities? How about 3 years? What's your guess where these things might be moving?
I think within the next year, we're going to see a lot of fully automatic coding loops where we basically cut the human out of the loop entirely. I think that those are going to be mainly in areas with highly measurable feedback functions. Like, for example, a model has a loss function. You can say, find the code change that minimizes this loss function. It's very measurable. Or optimize this kernel, make this kernel run fast. Like cases where there's a really refined feedback or there's very measurable feedback. I think we're going to see the human out of the loop in the next year. I would not be surprised if the world completely changed in 3 years. Like, it could be the case where things are just moving so quickly that very quickly, even today, we're starting to see human review be the bottleneck, where AI agents are able to produce code so much more quicker than humans can actually audit it, that I'm not sure if we're going to be able to have humans audit code 3 years from now. It might be the case where we basically have these sort of self-modifying systems that humans no longer understand in 3 years.
That brings us to a very interesting thing. Programming languages were created for humans to write. Now humans are not writing it. And you are saying humans might not even audit it. So will programming languages change? I mean, where should we, what should you, you're writing in English, obviously, the specification out there. What will be the next layer?
That's a really interesting question. On one hand, like, in theory, like, there could be like way better languages designed for machines, and some like the language I'm working on, Helion, like, a lot of what Helion is designed for is auto tuning, and we're using agents in our auto tuners now. The idea is, like, if you're picking like all the eviction policies for all your stores, you can just express that as a vector, or something like that. But on the other hand, all of the training data that these agents were trained on was on human programming languages. And so one thing I'm wondering is, have we reached the end of new programming languages? Because any new programming language that we introduce won't have any training data for it. And so the agents will just inherently be terrible at any language which isn't in their training data. And so it could be the case that just like no new language can get off the ground because there's sort of this bootstrapping cycle that we can't overcome. And so I'm not sure which of those camps we're going to land in, but I can see it going either way.
Yeah, that's cool. There's this question. Do you have any tips on managing limits? I guess you might have a much bigger budget than a lot of us do. I have find myself depleting my tokens fast when not micromanaging the reasoning level for each task. Do you find?
Yeah, this is one of the advantages of working in a large company is that you do have an unlimited token budget. That's where the bill is getting picked up by someone else. I do a lot of stuff with just the max plans, like the $200 a month plans from OpenAI and Claude and Anthropic. Both of those, like, $200 a month plans have pretty generous limits, and I think it's totally worth upgrading to the bigger plans.
Okay. Other questions? Okay. One other question, Jason. How many parallel agents you have run at a time, and do they run into each other? I mean, how do you manage multiple things getting into the same code base?
So this is why I'm using Docker. So this is sort of what this slide was about. So I have between 1 and 4 Docker containers running at a time. Mm-hmm. But basically, the way Docker works is it's an isolated environment. So basically, the working tree of one container is just entirely separate from the working tree in another. And if I want to spin up a new project in parallel, I'll start a new container. That new container is separate, and it won't stack on each other.
But in the same project, how many agents you normally let loose on the same code base?
I have one Claude and one Codex in 2 separate windows, and sometimes they're running and doing different. Sometimes one is reviewing and one is coding, but I try to avoid having 2 code at the same time because they clobber each
other. Okay. Any other questions? If there's no questions, I really want to thank Jason. I think this was a great talk. I think a lot of us learn a lot, and hopefully we can put these things to practice in there. And also, I am trying to see whether we should set up a series like this, and if you have either suggestions who should I invite, or request what type of people we should invite, is good. I am recording this talk and I have a list of everybody registered. Hopefully, I can send the transcript and the video to the list. If I can figure out how to download the list myself, or I should ask the agent to download it for me. We'll see. Okay, Jason. Thank you very much.
Yeah, thanks again for having me. Enjoyed it.